All right. Another alternative way, and this is just showing a few other functions that we have in WebbPSF. We're gonna do, maybe you wanna see how the PSF change, and in particular focusing on some of the properties of the PSF. We know that you can get encircle energy fraction and full width through WebbPSF itself. There are some convenient functions like measure encircle energy. You also have the measure full width. In this case, I'm using the previous simulation to just calculate some encircle energy, some metrics of the PSF from the simulation point of view. I'm gonna define this function. This is another convenient function that I use for the full width. You may have your own function, but I have found this very robust and convenient function to calculate the full width of a PSF. And based on the simulation, we can apply this function and calculate things like full width of high maximum for the PSF. So let's say that you have a simulated PSF, you can calculate the properties of the simulated PSF, and using the same functions, you can likely calculate the properties of your observed PSF. And I wanted to show you that once you set up your simulation, even if you do this via your setup with file or manually, once you set up that and you load your OPD files or your face map file, you have access to that file inside your instrument object. Once you load that, you have access to the file. If you just want to corroborate that indeed you loaded the correct file and that indeed you are doing the correct simulation, if you do that, you can load that, and as before, you can see the header information of that OPD file. So this is a way, once you set up your observation, you can always double check that you have the correct OPD files, and at least you can see where that file lives. In this case, let's say that I want to see another PSF because I have two programs and I want to focus in particular about two different PSF that have the same instrumental configuration, but maybe the OPDs were a little bit different, because one happened when we have an event, and the other one happened when we have a very stable telescope, and you just want to see, based on the simulation, do you expect to see big changes on the observed PSF, right? So I'm calculating this here, another PSF. I'm just using exactly the same instrument object that I defined early with my file. The only thing that I'm doing is changing now the OPD to a different file. And I can calculate the properties again. I can compare that to what I did before. And I have a very convenient function on WebbPSF that is display PSF difference, where I just pass the two different simulations of the PSF that I have, and then I just basically calculate the difference between those PSF. So I wanted to show you this because it uses a convenient function on WebbPSF and allows you to see how different in simulation world are two PSF at two different times for likely the same program, right? This is more getting into the details. So now you have that information that you can use for your own observations. Now, doing all this setup of the WebbPSF and setting up the OPD file, by default, WebbPSF has already an OPD file that uses by default, which is an OPD that happened, it is for the optical performance of the telescope that happened at the end of July 2022. And we choose that file by default because that's sort of like, well, that's a file by default. Maybe we'll change that in the future, but that was sort of like a not optimal OTE performance, right? So by default, you have a file that is going to give you not necessarily the best PSF, but it gives you a PSF that was typical early on commissioning. That's why we have done all this, is for you to use the correct OPD file. But in any case, once you have that, you can, for instance, these are examples. You don't necessarily need to run this right now, but this won't take much time, where you can just loop over. Let's say you are thinking how Miri looks at different wavelengths with that particular OPD by the time of my observations. So you can calculate, for instance, you can loop over Miri. We have monochromatic wavelengths. You can loop over a set of wavelengths. This is going to be relevant if you're trying to set up, for instance, a Miri cube, and we'll see how we have a very convenient function at the end of the notebook that allows you to set up a Miri cube if you are doing IFU investigations, for instance, Miri and near spec as well. So with this, you can just run these cells and you see visually how this PSF with that particular OPD, with a particular configuration for your detector, for you, in this case, a monochromatic observations, how they change for a particular set of observations or what to expect. In this case, is taking longer than intended. It is okay. We can do the same setup for near spec. Again, remember that you can set up your instrument. You can load your OPD file directly for a particular date. In this case, you know already the OPD files because you have the information either from your OPD difference, from your OPD table, etc. And you can also check and download and create a, for instance, a visual representation and how this PSF looks at this particular and different wavelengths. Remember that WebbPSF also support other modes, not necessarily only imaging, like NearCam or NearIS. Here is an example where you can retrieve a lot of information, all the intermediate planes that are going through the WebbPSF simulations. So you have access to all that information. In this case, this is an example of an MSA all open, where you see the PSF, the final simulated PSF. Or maybe I can try, see if I can get the same error here. It's just taking longer than expected for this. In any case, again, with Miri, we can do the same setup. Not necessarily that you have to run this, but I want you to have this in the notebook. But many of these things, some of these cells are not running, but many of those things are being sort of like taken care of in some recently added functions that are intended to increase WebbPSF support for IFU observations, IFU simulations, both for Miri and for NearSpec. So in this case, for instance, we can create a data cube for Miri and NearSpec observations based on their normal setup in terms of filters and etc. And this will create cubes that will mimic the observed cube that you get on this, right? So I can see that based on these simulations for these IFU cubes that you get from WebbPSF, you can use those to subtract your PSF from your IFU observed cubes. Now remember, once you do this setup, it is the same as I mentioned before, that before you do your PSF calculation, you can always change properties of the instrument itself. In particular, your detector effects, your charge diffusion. These are things that you can set up and change to better match your observations. You're likely going to find that you need it a bit more broader PSF than normal, and then you just increase the value by a little bit. But in any case, all the setup that I showed you before, when you have that monochromatic PSF, specifically if you want to see for a particular bands, you can also get all that with this convenient function that allows you to create these simulated cubes for you to remove the PSF from your IFU observations. Now note that these cubes, it's something is still running up, and likely just it shouldn't take this long. But note that these cubes, for instance, if you download the stable version of WebbPSF, you'll likely get some issues because I think there was a change on AstroPine on how it handles some of the numbers. So if you get issues running this particular set of functions, make sure that you download the developed version of WebbPSF because that issue has been fixed.